All right, it might be a little early, but I think I'm actually going to go ahead and get started, just so maybe I can have 1 or 2 extra minutes. Hopefully I don't go over, but when I timed this, it got pretty lengthy, but we'll see. Well, all right. Thank you all for attending. I understand there are quite a few competitive talks in this time slot, so even I personally am going to be going and rewatching, or watching that RPG, like that video game one after this. That one looked pretty cool. But mine's going to be pretty cool too, especially if you're unfamiliar with the things that I'm talking about. Hopefully you can learn something, add a nice little useful tool to your tool belt after my talk. So yeah, I am Chris Fries. I am a Elixir backend engineer, PepsiCo e-commerce. I've been doing Elixir since about 2016 or so, maybe even as early as 2015. I was like looking at it. I'm an Austin, Texas local, and yeah, my GitHub is CJ Fries, and my Twitter is Chris Fries Dev. A little bit about PepsiCo, obligatory. We have a lot of really cool brands, not just Pepsi Cola, the soda, and so here are some of them. Probably a few on there you're not familiar with. I just think it's cool that all of these random brands out there that I have eaten at any one time or another just happens to be owned by PepsiCo, and that's kind of cool. So the reason why I am giving this talk is mainly to introduce a library which I call ChoreRunner. And if any of you recognize the font there, yes, it is a Blade Runner reference. Despite the cool name, it's a really simple library. But before I get into it, though, I'd like to talk about something first. I love Elixir. It's great. Elixir has a ton of extremely cool and useful features in it. And one of the reasons why it has so many cool and useful features I'll get into, but one of the features I want to talk about first is IEX. I love IEX, and IEX shells are like, especially remote IEX shells are extremely useful for debugging and playing around, and just generally it allows really fast feedback between you and your project. So I have some audience participation here, or I want some audience participation here. Show of hands. Who has production Elixir experience here? That is a ton. Compare that to like the first or second ever ElixirConf. There's like barely any hands. It's crazy. Who here has ever remoted into a production IEX shell for debugging? Nice, nice, nice. Who here has ever copy-pasted code into that production IEX shell? Oh, that's a lot of you. Wow, that is maybe a little worrying. This is my favorite. I do this all the time. Confessions of a developer. Who here has ever used IEX to replace an entire existing module in production to avoid like the I don't want to have to commit this change. I just want to see if it works, and you just yeah, that is extremely dangerous. Don't ever do that. All right. What about databases? Who here has ever remoted into a production database instance? That's a lot. Nice. I mean, there are pretty common reasons to do that. Who here has manually run a destructive query in a production database instance? Wow, just about the same amount of people. That's pretty common there. And no shame if you don't want to raise your hand here, but who here has ever made a mistake doing any of these things? That's a lot of people. Yeah, so there are plenty of stories we shared about these kinds of mistakes. Some of them only get passed around in passing in the office, and some of them make international news. Let me share a story I heard from PepsiCo Ecom's previous SVP, Mark. Mark had a long history of working in various tech companies before he joined Ecom, and of course that comes with his fair share of mistakes. He told me about once he was working with this live event ticketing company, and how they had an event with the title that was just Super Bowl, because the teams weren't decided yet. And so when the teams were decided, he's like, okay, I'll just remote into the database real quick, and I will update that to reflect what teams are actually playing each other. So he did so, and he ran a query that probably looks something like this. Does anyone see the issue? Yeah. So he hit enter, and before he could even read the number of rows that were just updated, every single event in his system just had its event name changed to Super Bowl, Team 1 versus Team 2. Luckily, they had frequent database backups, but that's never a fun day at work. really, mistakes like this are just a symptom of moving fast. Oh, yeah, I have an error there. Whoops. At PepsiCo, we move pretty fast, maybe faster than you would expect for a company of our size. Since the first launch of Pantry Shop in April of 2020, we've added 5 new stores to our e-commerce platform. Pretty much all of our developers are always working on new features or shops at any given time. And that means that certain infrequent activities simply aren't worth the time to be solved in a proper fashion. Here's an example. When we first worked into selling a variety of PepsiCo products online, we quickly learned about bottler agreements. Bottler agreements are essentially contracts which give certain bottling companies exclusive rights to distribute in their markets, which are geographically based. For bottlers not owned by PepsiCo, we had to ask them for permission to sell their products or sell these products in their regions. And those bottlers requested to choose which zip codes we could sell certain products to on an opt-in basis, and that was the deal. That's great and all that we can, at least have some opt-in, but our platform didn't support that kind of restriction. Time was of the essence, and we wanted to be able to sell these products as soon as possible, so we speedily created a rule system. It was a pretty simple system. Basically, products can implement rules, and zip code rules can have a bunch of excluded zip codes. A product with a zip code exclusion rule can't be sold to you from our store if your billing or shipping address matches any of those excluded zip codes. So how do we know what zip codes to add to each rule? Well, the business gives them to us in the form of several Excel documents that change every month. Updating them turned into a bit of a chore. So it started out with copy-pasting a script module that had all the zip codes hard-coded into it, and taking that script module and putting it in a production shell, right? And then we would run it to configure the rules. This was a bit stressful as this script was upwards of thousands of lines due to all the hard-coded data. And we wanted a safer way with minimal dev downtime spent on it. So I implemented the first pass of the chore system. Well, it wasn't really much of a system though. It was just a single behavior that looked like this. So with this, it's pretty simple, but despite its simplicity, I had 2 main goals that I wanted to accomplish here. The first was speed. I wanted to try and retain as much speed as possible. The whole reason we used remote shells in the first place was because the frequency of updating these zip codes about once a month didn't really warrant writing a whole specialized admin feature for it. It's faster just to use that production IX shell. The second goal was safety. In many cases, mistakes with these things could have legal ramifications. We misconfigured something that could result in a breach of a bottler agreement or charging the incorrect amount of taxes. I figured this could be prevented the same way we try to prevent mistakes with non-chore code, which is just testing and code review. By including our scripts as application modules, they can be tested in CI, reviewed by other developers, and easily trialed in staging environments. Oh yeah, that safety. Yes, fast and safe. Very nice. Some of you might say that speed and safety are mutually exclusive, or that it's always a trade-off. And I agree, though I imagine it as sort of like an uneven gradient between the 2 goals. I wanted the best value solution which maximized each goal as much as possible. And while it's something that was usable in the short term in the form of that behavior, I was far from finished. I mean, we still had to connect to a remote IEX shell to even run these chores. So our chore system eventually turned into ChoreRunner. From the beginning, my vision was a much more feature-rich and open source library that truly found the sweet spot of speed and safety. For starters, I added a simple public interface for working with chores. Lets you run chores, see which chores are running. It's not shown here, but you can also, stop an existing chore, or early just in case you didn't mean to do that. I expanded the chore behavior to also offer a simple framework in DSL. Let's look at an example implementation. Simply use ChoreRunner.chore to get started. Then once you've done that, you can take advantage of the dynamic input definitions and validations part of the framework. The system offers multi-node concurrency guarantees, a simple and intuitive logging DSL that broadcasts chore updates over PubSub, and a plug-and-play live view UI. And of course, I have a demo. So let's get into that. All right, so here's an example of a chore. It's completely empty. Ignore that. And here are 2 browsers, both connected to different nodes in the same cluster, running the same code, basically. So for starters, if we run a chore on one, this empty chore, it instantly completes on both nodes. It's distributed. It's supported across nodes because of PubSub. And we can dismiss them individually on each browser. Now let's maybe have it do something over here. Let's have it say hi to us. And let me, yeah, there you go. Can everyone see that?
Yes.
Cool. All right, so let's have it say hi. First of all, we need to reload both browsers so that both nodes recompile. Then if we run, we can see that it gives us a nice little hi message. Well, what if we want to take some input? Well, we can go over here and we can define the inputs callback. Let's make it say hi to us based on name. We need a string input name. Cool. Now, let's reload. And we can see that the run chore has automatically generated the name field for us. So if I put my name in there and I run the chore, oh, I forgot to use it. Of course, it's kind of nice if you actually modify the implementation to use the input. But yeah, as you can see, we can just pattern match on the expected key right here. And then when we go back in here and we run it, hi, Chris. Hello. Yeah, these inputs also support those validations, right? Let's see, no, Jason is not in here. I was going to heckle him a little bit from up here on the stand. Well, I'll do it anyway, even though he's not here. So let's say I wanted to prevent the system from saying hi to Jason. I could say validators. And then I could say no Jason. And if the name is Jason, and then, of course, for everyone else, I'll just say OK. Then over here, we capture.
I think you forgot the
Yes, I did. You're right. And make sure. Oh, I forgot a bunch of things, but it's all good. Now it'll work. So if I go over here and I type in Jason over here, we get a nice little error message. Of course, live there. But Jason's smart. He's a very smart engineer. He's just going to amend that lowercase there, right? Well, we can solve that by just putting in another validator that also modifies our input by just calling string.capitalize here. Validators can also be used to transform input. So now if we go back over here and we refresh and we type Jason here, and as a bonus, if I type Chris right here and I run chore, it capitalized my name for me. And finally, one of the cool things that this system does is it prevents you from running more than one of the same chore at the same time based on a configuration. So right now we've got this chore running, right? Or not finally, I actually forgot one of the coolest features, but we'll go over that real quick. So let me just sleep here for about 10 seconds. So that way, it takes a while for each chore to complete. So if I run it, you can see it still says stop up here, right? I can actually kill it at this point and then dismiss it. But if I run it multiple times, it doesn't work because it's already running. And if I try to do that on the other node, it also doesn't work because it's already running. But I can configure that with the restriction callback by saying restriction none. The system then lets me spam as many chores as I want, which is nice and fun. And finally, let's say you want to get some nice counters, oh, I want to see how many rows of data I processed here, or percentage. Well, we can do something like this. Using the set counter, there's also an equivalent inc counter for incrementing. If you don't want to have to keep track of the count yourself, you can set a nice little data value. And the reason why that instantaneously completed is because Elixir is so fast that it counted from 0 to 100 and sent 100 of those messages faster than it could even render the interim. So I have to put a process.sleep here. Let's try this again. We can see it will give us a nice little count to 100 there. And it did so on both nodes. And that's pretty much it for the demo. So yeah, thank you. Oh, I got 20 minutes left, don't I? Well, don't worry, that's not actually it. I intentionally have this much time left, and that's because the real purpose of this talk isn't to announce my library. ChoreRunner isn't really groundbreaking. This isn't the next live view. It's actually, in fact, remarkably simple behind the scenes. But that's exactly why I wanted to give a talk about it, because it combines many of our favorite buzzwords like OTP, metaprogramming, PubSub, and live view into one useful tool, which makes it the perfect example to talk about those things. And, of course, share what I've learned with all of you so you can maybe use it practically in a production scenario. So we saw several things on the demo. We could track a chore from start to finish. We could see chores on every node and prevent conflicting chores from running simultaneously in a distributed system. And we implemented callbacks and used imported DSL functions to build chores from scratch. That's quite a few features. Is the implementation really so simple? Well, let's dive in and find out. So the first thing I wanted to share is ChoreRunner's use of dynamic OTP, which is an OTP use case I really don't see much in my everyday coding. Chores only run when you tell them to run. We also want to isolate the running chore from everything else rather than running chore on whatever process happened to kick it off, so that exceptions are isolated. This includes separating the reporting process from the chore process itself, so even that catastrophic failures are properly recorded. This ends up being a great use case for a task. But not that type of task. We can't use that. Task.async links the calling process to our chore, so the exceptions kill them both. We could call unlink, but there's an easier way. We can use task.supervisor.async no-link. All tasks started this way will be linked to our chore supervisor, which can then notify the calling process when our task finishes and exits, including for unhappy reasons. This is only one half of the puzzle, though, as we need a separate dedicated process to receive these messages. One way we could approach this is using a dedicated worker process, which reports on all chores across of a node. But instead, I opted for a more dynamic solution of starting one gen server per chore. But we still need these processors, the reporter processes, to be supervised, though. So we can use a dynamic supervisor to start and supervise them, at least until we want them to die. When a reporter is spawned, it's in charge of starting the chore. The chore's task supervisor registers the starting process to receive task lifecycle messages. And that's always in this case, the reporter is the one that always gets registered. If we want to know when the chore has finished, whether gracefully or not, all we have to do is listen for the right message. These messages go to the handle info callback of our reporter gen server. We can receive two different types of messages here. One is the happy case, where the chore ran to completion and even gave us back a result. The other will always be received if the chore exits, regardless of reason. That means for success, you'll get one of these messages in addition to the previous, but it can also give you other reasons, such as exceptions. That's all we need to track when a chore ends, but what about what things that happen when a chore is running? Well, we already saw code like this during the demo, as well as a bunch of helpful live information about the chore's progress while running. But let's look at some of these reporting functions behind the scene. Okay. All these functions just call genserver.cast. This asynchronously sends the information to our reporter, resulting in minimal slowdown of our chore's execution time. Sending a synchronous message with genserver.call would work, but it's much slower. And it's okay if the reporter runs a little bit behind the chore itself, as every message will get there eventually. But what is this magic function getReporterPID? And clearly it returns the PID of the reporter, but it accepts no parameters. So how does that work? It could work in a number of ways, such as using a registry or some sort of common name scheme, or could use something a little bit more magical called the process dictionary. If you're unfamiliar, all Beam processes have a mutable key value store accessible anywhere as long as you know the process's PID. While I generally wouldn't recommend using it where you can use a parameter or a variable instead, it's great for library and logging convenience in a controlled setting. In fact, Elixir's own logger uses it for storing metadata. So how does this work in ChoreRunner? When the reporter starts the chore task, I just put the reporter's PID inside the chore task before calling the chore's run callback. As a result, getReporterPID can then retrieve the reporter's PID at any time to talk to the reporter. And it's really that simple. Except there's actually a problem here. Done this way, the chore process only has the reporter PID stored. And that might not seem like a problem, but this is Elixir. And in Elixir, we like to do things like concurrently, parallelize stuff, because that's a little bit more efficient. We could use task.async stream in order to process stuff in our chore, and that would be much faster than doing it one at a time. But if the chore process, or if the reporter PID is only in the calling process, then those other PIDs, or those other tasks started in async stream, can't use reporting. And limiting our chores to a single thread isn't very Elixir-y. But there is a cool solution that retains the magic of our original Git reporter PID. A lesser known fact about tasks in Elixir is that in certain situations, it will record its parents in the process dictionary. For example, here we have a task called task A. If task A spawns another task, which we can call task B, the spawning task's PID gets copied into the spawner's dictionary under the dictionary key $callers. If task B spawns another task C, it will copy both its spawners and its spawner's PID into $callers. But what can we do with those PIDs? Well, I mentioned earlier that the process dictionary can be accessed by any process as long as you know the PID. This is done with the function process.info. Simply call said function with the PID and the Atom dictionary, and you're good. You got it. So with the PIDs found in callers and the process info function, our Git reporter PID implementation now works in any task spawned by our Chore process. So that's pretty much it for like Chore tracking and stuff. Besides the message accumulation logic, of course, but that's really just putting data in a struct. I think you all know how to do that, so I'll skip that for the interest of time. Next, of course, I want to talk about distribution. One of the things that makes Elixir great is how easy OTP makes running stateful distributed systems. Many apps run multiple nodes clustered together via the beam, and I definitely needed to make sure that ChoreRunner would not work unexpectedly in multi-node apps. There are two main problems that need to be solved here for ChoreRunner to work. The first problem is relatively simple. The list running chores function on one node needs to be able to find all the chores on other nodes, not just locally. There are many different solutions here, like possible solutions, but I chose PG. PG stands for process group. As the name would imply, it lets you create groups of processes. You can then ask PG to list all processes in a group and then iterate through them to communicate with them. And if a process dies, it's automatically removed from the group. The best part is it works multi-node right out of the box. All you have to do is add a reporter to the group after it starts. And then after that, if I want to list them, I can just ask the PG for the members. And that's pretty much all we need for our first distribution problem. The second problem, though, is a bit trickier. Miscommunication, or the lack of communication altogether, is a source of many a mistake in the world. One of the potential issues I saw when writing ChoreRunner was if two developers both tried to run certain chores at the same time. Who knows what chaos could result from two chores making the same or similar changes simultaneously? A simple solution could be just to mention it a precaution section of the README and move on, but that would result in additional things a developer has to worry about, and nobody likes having to code defensively. We could use my list running chores function before running any chore and check manually, but that could pose a problem. PG is kind of lazy. Its groups are strongly eventually consistent, which means states can temporarily diverge. In addition, group membership isn't transitive. So let's say we have three nodes with some minor net split. Node A can see node B, but cannot see node C. That means node A can only see group members in nodes A and B, even if node B can see all of the group members. For the list function, this is okay because that function is really only used for the UI. And we don't necessarily need to have perfect introspection there. We can potentially just try and hit the load balancer over and over again and see it in like a disaster scenario, but that's really not very relevant. But instead, I needed something with a bit stricter to solve this problem, so I went with global. It's yet another Erlang module that offers several conveniences for working with multi-node systems, such as a distributed registry and distributed locks. If you've ever dealt with a multi-node name registration for Gen servers, then you've seen its registry functionality. But today we'll be looking at the lock functionality instead. Locks are simple. If you lock something, nothing else can lock it. If someone tries to lock the same resource, it will synchronously block until the resource is unlocked. It can then access that resource. But it can also time out if it takes too long. Let's see how this looks in code. All I need is the resource to lock and the list of nodes to lock on, which in this case is always all nodes. Okay, I'm just going to leave it like that and keep going. We don't even have to call global.deleteLock, which is how you would normally remove a lock, to release the lock afterwards, because they also get released if the process dies, similar to how they get removed from a process group if the process dies. That way, when the chore ends, it automatically releases its lock, and then something else can then go in. But what is a resource here? Well, it depends on the chore's restriction callback. For global, I just lock the atom global. For self, I lock the chore module name, and for none, I skip the lock step entirely. And that's pretty much it for distributed chore management. I may have made it seem simple, and indeed the implementation is simple, so let me state a really quick disclaimer here. Distribution is a complex topic. Off-the-shelf solutions are great for simple applications like ChoreRunner, but are no means a one-size-fits-all solution. While PG or global could work to help you solve your distributed problems, you should definitely evaluate many different implementations and weigh their differences when trying to solve distributed problems in a productionist scenario, especially something user-facing. So let's switch gears here. Let's talk about behaviors. Sorry, hold on. There we go. Behaviors offer a great way to define a framework with which users of your library can write code which works with your library. Since Elixir is, of course, a functional language, as long as your callback function definitions meet the spec, you're good. Sometimes callback specs can get a little complex, though. Imagine having to manually build and transform a plug.conf. It's often a good idea to provide additional functions that can be used within the domain of your framework to make it easier to conform to a more complex specs. Broadly, you can refer to the resulting syntax as a domain-specific language. Many libraries offer powerful DSLs through the use of macros. A notable example is Ecto. The Ecto query DSL may have taken some time getting used to at first, but it's very powerful to those who understand it. But there are always trade-offs. For example, let's take a look at the Chore DSL. If we take a look at this example Chore input callback, we see that it's a little bit more complex than what we saw in my demo, or actually it's about exactly the same complexity. This was written before I'd planned my demo. Anyway, now let's, without any other context, take a look at a different definition, or the same definition, I should say, but in an earlier version of the ChoreRunner library, which looked like that. The old approach uses data and functions, or the current approach uses data and functions, whereas the old approach uses pretty macros and magic. Ultimately, though, they compile to pretty much the same code and work in the same way. Now, I'll be honest. I may have moved away from the macro approach, but I still kind of miss it. It's very pretty, and it looks like it would be faster to write too. So why did I move away from it? I actually had to do a lot of work behind the scenes to get it to work. So it was very difficult. It's like, sunk cost, right? Plus, less code is faster to write, right? Well, this pretty code has a dark side. Behind the rosy exterior lies a mess of compile time code generation. It claims to define inputs for your chore, but how it does it is unclear. If you wanted to know how it worked, you'd have to go digging through quite a few lines of source code macros to figure it out. You'd learn it generated a bunch of functions, iterated through the abstract syntax tree of the input macros do in block to capture those validator functions into the validation logic, which was generated at compile time. And it had some dirty hacks to make sure that the contents of each input's do in block actually triggered correct compilation errors, if there were any. But even if it was a bit messy, it still worked. So why would we change it? Well, if I'm talking about macros, I'm obliged to mention, of course, this meme. Rule number 1 of Macro Club, don't write macros. I was still caught up in how nice my code was and how much fun I was having writing the macros. I broke several macro rules along the way. But the main one that I will cite today is this. Don't write macros if you can write a function instead. Or I guess more appropriately for me, if you can make your library's users write a function instead. Ultimately, the code I was generating was not complex at all. It was so simple, in fact, that I could simply document the structure, define a callback, and let the developer write it. The only mystery here is this string function. Let's take a peek into the source and see what it does. So here, as you can see, I actually managed to sneak some metaprogramming into the library, but there's not really anything complicated here. If we expand this out after compilation, it would look like this. It's just 5 simple functions that output some happily formatted tuples according to the input callback spec. In addition to this, there's actually one more useful macro being implemented in ChoreRunner. This is, of course, a using macro, which are one of the more common macros being implemented across Elixir. For those of you who are unfamiliar, this is what actually gets called when you call use anything, including use ChoreRunner.chore. At the top of the, when you call, so for example, if you were to call use ChoreRunner.chore, which you've seen at the top of the chores thus far, it would call this macro. And this is vital to the functionality of our DSL. Let's look at what it does for us. So it gives us a few aliases and imports. That's nice, convenient. It flags what behavior you're using or we're implementing, which is nice. That way we get those callback warnings. It defines some default callbacks and functions so that we don't have to implement every single callback. It's also very nice. Marks them as overridable so we can define our own if we choose, and provides a little validate input function that's really just a convenience to me, the developer or the library writer. So yeah, that's pretty much it. Yeah, anyway, sorry. I guess the takeaway here is that in many cases, you can write convenient and intuitive DSLs and frameworks without the use of heavy macros that disguise functionality from the user. But at the same time, metaprogramming is still an important feature of Elixir that can be used with great success if used responsibly. And that's pretty much all for the framework, as well as the lesson learned while writing it. And yeah, that's all of our cool features covered. We use tasks, dynamic supervisors, gen servers, and the process dictionary to enable our chore reporting, PG and global to power our distribution logic, and learned about when to use and when not to use macros while writing a simple DSL or framework for your library. And that unfortunately means we're approaching the end of my talk just in time too, so I have one last thing to say. I love Elixir. Elixir and the technology it's built on enables me to build things like ChoreRunner. Major problems that other languages would face around concurrency and distribution are effortlessly solved. And the resulting code is clean and nice to look at. There's so much that the language has to offer, and that's one reason I love coming to ElixirConf, is so that I get to go to talks and learn about features and details that I didn't know before, and then turn around and use those things myself. This is actually my first ever talk at ElixirConf, or pretty much ever. This was also written before I was invited to give a talk at NervsConf on Monday, so that's not true anymore. But I still thank you all for being a part of this historic occasion for me. I wouldn't be able to be here giving a talk without all of you, and so hello. Oh, there we go. Thank y'all for coming to my talk. I hope you learned something. I also hope the ChoreRunner gets some good use out there after this. There's honestly a lot more I wanted to talk about too, such as some of the things I was doing in LiveView with the dynamic form building and also packaging it into my library. If you'd like to hear about that, or feel free to talk to me more in the hallway or reach out on Twitter or Slack. Or if you'd like to do some self-study, you can always just check out the source on GitHub. ChoreRunner is open source, though we are not currently accepting open source contributions, unfortunately, though we hope to be able to in the future. But for now, if you have an issue while using it, you can open a GitHub issue to address it. Once again, I'm Chris Fries with PepsiCo Ecom. Thank you. And I think we have maybe a little bit of time for questions, or, well, I don't know where the MC is. So ask away if you have any. Yeah.
The ChoreRunner UI is available when you install the library. If so, how did you package that? How did you make that available?
Yeah, so a little quick comment about that. Probably eventually the intention is to separate out ChoreRunner from the UI, but now they are together. But either way, I'd still need to answer your question about how to package LiveView into a library. It's honestly pretty simple, but there's not really any way to just oh yeah, just use the dep and it works. You still have to essentially call the LiveView like you would any other LiveView. But ultimately, these OTP processes, or these LiveViews are just OTP processes. Just the way that you would get like a library and then throw like a supervisor into your application, you basically just take the LiveView and then throw it into your router, and it pretty much just works. The main thing to keep in mind, though, is what to do with static assets like CSS files and whatnot. Luckily, applications do come with priv directories. It's a default that your priv directory will be forwarded along with your dependency if you define it to be that way. So you can just throw it all in there. I would recommend that you make the CSS files and JavaScript files compilation time assets. And then if you want to be able to reference images using sendfile, you're going to have to use application.appdir with the priv option. It's kind of weird. I can go into more detail about it later, but yeah, it's honestly not that hard.
It seems like to me a major use case of this would be jobs that are supposed to run one time. You have a fix that you need to do. But the way this is set up is it's forever there until you kind of delete the job, right, or the chore.
Yeah, essentially, yeah. And it's not necessarily that you would want to run at one time. For example, the main use case we're going to use it in PepsiCo is updating rules that constantly change due to business requirements. And it really just, we're just expecting that they're going to come up with new rules that we need to implement. And instead of having to create a brand new admin interface for every single type of rule we want to change, we can just use ChoreRunner. But yeah, you could also use it for one-once things, and we've actually done that plenty of times with the existing chore system. We just clean up the chores once a month. It's okay, this directory is getting a little big, just delete it, There's nothing wrong with deleting code, at least in my opinion. Yep.
Do you recommend deploy your application with Chore and
Definitely the former. I would not ever run something locally and then try and connect it to production. The idea is that this can just be plugged into like an admin, generally if you're writing some sort of web app, you're probably going to write some sort of simple admin portal that only your developers or you can access, and you just throw this in there. Yep, any other questions? Yeah.
Are you related to Jim Freeze, the organizer of this conference?
Yes. Full disclosure, he is my father. But I hear that he has absolutely no say in what talks get accepted, just for the record. Yes.
Who is the person on that screen?
That's my younger brother. He's a little bit better looking than me. So I use his picture instead of me. Our faces are pretty similar, but I've got this hat surgically attached to my head. Yeah, any other questions? All right, thank you.